The first time a human being looked out a window in orbit, they went quiet. Not because there was nothing to say, because there was too much, because nothing in their entire life, no mountain, no ocean, no photograph, had prepared them for what was actually out there. And the strange part, it wasn't the stars that did it. It was something else entirely. Today, we're going to talk about what astronauts actually see when they leave Earth. Not the version from posters or movies, the real thing, described by the people who've been there, backed by the science of why it looks that way. And some of it is beautiful. Some of it is deeply unsettling. All of it is stranger than you'd expect. It starts before you even get there. During launch, there are no windows pointing in a useful direction. You're pressed into your seat by forces equivalent to 3 times your body weight, like someone stacked 2 copies of yourself on top of you. And the ride is loud and violent, and nothing like the smooth simulations on the ground. For the first 8 minutes, you see almost nothing, and then it stops. The engines cut out, the noise disappears, and suddenly you're weightless. The first astronauts who experienced this described it as one of the most disorienting moments of their lives. Not unpleasant, just completely unlike anything the human brain has a reference for. Your body doesn't know what to do with the absence of gravity. Your inner ear, which has been telling you which way is down for your entire life, goes silent. And then someone floats to the window. What they see, at that moment, is Earth, but not the way you've imagined it. It's not a perfect blue marble hanging in the dark, the way it looks in famous photographs. At low Earth orbit, roughly 400 kilometers up, where the International Space Station lives, Earth doesn't look like a planet. It looks like a surface. Like you're flying very high over the most beautiful landscape you've ever seen, except the landscape goes on forever in every direction and curves away at the edges in a way that makes your depth perception give up entirely. The colors are the first thing astronauts mention. Not one blue, dozens of blues. Shallow ocean water over sandbars in the Bahamas glows a color that has no name in any language most people know. The deep Pacific is almost black. The Sahara is orange and pink and gold, depending on the sun angle. Thunderstorms, viewed from above, look like slow, white flowers opening and closing across the surface. But here's where it gets strange. It's moving, all of it. The ISS completes 1 full orbit of Earth every 90 minutes. That means astronauts see 16 sunrises and 16 sunsets every single day. The Terminator line, the edge between day and night, sweeps across the surface in real time. You can watch the shadow of night chasing the light across an entire continent in the time it takes to eat a meal. Astronaut Ron Garan, who spent 178 days on the ISS in 2011, described it this way. The view was so beautiful that it was almost painful. And then he looked more closely, and he could see the thin blue line of the atmosphere, this almost impossibly thin shell of air that separates everything alive from everything that isn't. From up there, it doesn't look protective. It looks fragile, like the skin of a soap bubble. That thought has stayed with almost every astronaut who's seen it. Here's something most people have never thought about. In space, the sky is not blue. The sky doesn't exist at all. On Earth, our sky has a color because the atmosphere scatters sunlight. Blue light bounces around more than red light, and so the whole sky fills with it. That's why on a clear day, you look up and see blue in every direction, even the parts of the sky nowhere near the sun. In space, there is no atmosphere to scatter anything. So when an astronaut looks toward the sun, which they can't do directly because it would instantly blind them, the area around it is not bright. It's black, completely black. The sun sits in the middle of absolute darkness, and it is the most intense light you can imagine. Astronauts describe it as almost violent. It doesn't glow. It doesn't have a soft edge. It's a perfect hard disk of white fire surrounded by nothing. Turn away from the sun, and it's darker than anything you've ever experienced on Earth. Not the darkness of a room with the lights off, not the darkness of a forest at night. True black. 0 photons. A darkness that has no bottom. Now think about what that actually means. On Earth, even in the darkest place, the middle of the ocean, far from any city, there is scattered light. Light bouncing off the atmosphere, off water, off clouds. The sky always contributes something. In space, when something is in shadow, it is in absolute shadow. Astronauts have reported reaching for objects just a few centimeters from their hand, inside the shadow of the shuttle, and not being able to see them at all. The contrast between sunlight and shadow in space is so extreme that the human eye cannot adjust fast enough. Step from sun to shadow, and for a moment, you are completely blind. This is why spacewalks, what engineers call EVS, or extravehicular activities, are so technically demanding. It's not just about the vacuum and the radiation. It's about working in a visual environment where the rules of light are completely different from anything human evolution prepared us for. And this is where everything breaks down, at least for our intuitions. We assume that with no atmosphere blurring things, space must be incredibly clear. And it is. But clarity isn't always an advantage. Without atmospheric haze, there are no visual cues for distance. Objects that are 1 meter away look exactly as sharp and well-defined as objects that are 1 kilometer away. Astronauts training for spacewalks spend hundreds of hours learning to judge distances in an environment where their eyes give them almost no reliable information. Here is one of the great surprises of space, and it's deeply counterintuitive. Most astronauts, during their first spacewalk, cannot see the stars. This seems impossible. You're in space. There's no atmosphere blocking your view, no light pollution from cities. You should be able to see more stars than anyone who has ever lived. And from inside the station, looking through specialized windows when the station is in the right position, you can. Astronauts describe the Milky Way as a thick river of light, not the faint smear most people see from the ground. But during a spacewalk, when you're outside and the sun is up, almost nothing. The reason comes down to the same physics that makes a camera struggle when you point it at a lamp in a dark room. The human eye, like a camera, can only handle a certain range of brightness at once. In space, during daylight, the sunlit surface of your spacesuit, the structure of the station, the brilliant surface of Earth below, all of it is so intensely bright that your eyes adapt to that brightness. And when your eyes are adapted to that much light, the stars, which are genuinely very faint by comparison, simply disappear. They're there. The photons are hitting your eye, but your visual system is overwhelmed. Except it doesn't stop there. When astronauts on the ISS move into Earth's shadow, into the 45 minutes of darkness they experience in each orbit, the stars come back, and they come back fast. Within seconds, as the intense sunlight cuts out, the sky floods with them. Astronauts describe this moment as one of the most stunning in the entire experience. Not a gradual reveal, a sudden appearing, like someone turned on a switch. Thousands of stars, then tens of thousands, then more than you can process. And the most disorienting part, they don't twinkle. On Earth, stars twinkle because their light passes through layers of moving air in our atmosphere, which bends and distorts the light as it travels. In space, that doesn't happen. Stars are points. Perfect, unmoving, unchanging points of light. Many astronauts describe this as deeply strange, because twinkling is such a fundamental part of how we understand starlight. Van Gogh painted stars that swirl. Every depiction of a night sky adds movement. In reality, from the right vantage point, the stars are utterly, completely still. In 1987, a philosopher and author named Frank White interviewed astronauts and cosmonauts who had been to space. He was trying to understand something they kept describing, a shift in the way they saw the world after returning, a shift that many of them struggled to put into words. He called it the overview effect. It's not a medical term, it's not a diagnosis, it's an attempt to describe something that seems to happen, consistently, to human beings who see Earth from far enough away. What they describe goes something like this. From orbit, the borders between countries are invisible. The things that divide us, politics, religion, nationality, language, have no physical presence from 400 kilometers up. There's just the planet, one object, surrounded by void, and it looks vulnerable. Edgar Mitchell, the 6th person to walk on the moon, described the experience during his return trip to Earth in 1971. He looked out the window at the stars and at Earth, and he felt, suddenly and overwhelmingly, that the universe was in some way conscious and alive. He was a trained engineer and naval officer. He had no framework for what he was feeling. He later said it was the most profound experience of his life and spent the rest of his years trying to understand it. Ron Garan called it an orbital perspective and said that seeing the fragility of Earth's atmosphere from above made the idea of nations fighting over resources seem almost incomprehensible. Not politically, almost geometrically. The planet is so small. The problems look so solvable from up there. But here's the problem. When they come back down, the feeling fades. Not immediately, but slowly, as the everyday world reasserts itself. As traffic and meetings and grocery lists accumulate, the clarity of that orbital perspective becomes harder to hold on to. Several astronauts have described this as the hardest part of the return. Not the physical readaptation to gravity, but the loss of a way of seeing. Would you go there, knowing that you'd have to come back? There are colors in space that humans have never needed words for, because until recently, no human had ever seen them. The sun, viewed from Earth, looks yellow-white. This is partially an optical illusion created by our atmosphere scattering the shorter blue wavelengths. The actual color of sunlight in space is closer to white, but a white that is more intense and more pure than anything you can see from the ground. Astronauts describe looking at sunlit surfaces in space and finding the colors almost overwhelming in their saturation. A white surface in direct sunlight is not just bright, it's nearly impossible to look at even in peripheral vision. And then there's the other direction. Astronaut Scott Kelly, who spent nearly a year on the International Space Station from 2015 to 2016, wrote about the experience of watching the sun rise over the Indian Ocean from orbit. He described the colors that appear in the thin atmospheric layer at the very edge of Earth, a band of gradient that shifts from deep blue to turquoise to white to orange in a strip that's maybe 20 kilometers thick when seen from above. He said that he had never seen those exact colors before going to space, and that he had no words for some of them, not because they were alien, because they existed in a range of transition between colors he knew, and the human color vocabulary doesn't go there. Now think about what that actually means. We have been naming colors for thousands of years. We have invented thousands of words across thousands of languages for every shade visible to us on Earth. And there are still colors visible to the naked human eye that no one named, because no one had ever stood in the right place to see them. There is a concept in Russian called goluboy, a distinct word for light blue, treated as its own color rather than a shade of blue. Research has shown that Russian speakers actually perceive light blue and dark blue as categorically different more quickly than English speakers do, because their language taught their brain to treat them separately. Language shapes what we see. In space, the language runs out. Here is a fact you know, but may never have fully felt. Space is completely silent. Not quiet, silent. There is no medium for sound waves to travel through in a vacuum, so there is literally no sound at all. The vacuum of space is the most complete silence in the universe. Now think about where the astronaut is. They're inside a spacecraft that is one of the noisiest environments ever built by humans. The International Space Station runs fans, pumps, ventilation systems, and equipment around the clock. The ambient noise level inside has been measured at around 72 decibels, roughly the level of a busy restaurant. Astronauts sleep with earplugs. The machinery never stops. And right on the other side of a wall that's a few centimeters thick, perfect silence. During spacewalks, astronauts can hear their own breathing, the hiss of oxygen flowing through their suit, the sound of their heartbeat in their ears. Nothing else. All communication happens through radio. When they're not talking, the silence is absolute, except for the machinery keeping them alive. Several astronauts have described this as the most alien sensation in the entire experience. Not the weightlessness, which the body adapts to surprisingly quickly. Not the view, which the brain eventually finds a category for. The silence, right outside, that you can almost feel but never hear. The absence of something so fundamental that your nervous system keeps searching for it and finding nothing. Astronaut Chris Hadfield, who spent months on the ISS and became well known for his calm and precise descriptions of space, said that the silence outside the station wasn't peaceful. It was enormous. The word he used was absolute. Not the silence of a quiet room, the silence of nothing, of a universe that has no mechanism for making sound. And that's before you think about what the silence means. It means no one is coming. If something goes wrong on a spacewalk, if your tether breaks, if your suit malfunctions, there is no sound of help arriving. There is no echo, no shout that carries. You are in the quietest place in the universe, and it can kill you without making a sound. Let's talk about what happens to time and space. On Earth, your brain uses sunlight to regulate almost everything. When light hits your eyes in the morning, it tells your brain to suppress melatonin and increase cortisol. Your body temperature starts to rise. You become alert. As evening comes and the light changes, the process reverses. This cycle, the circadian rhythm, runs in the background of everything you do, every day of your life, without you ever thinking about it. On the ISS, this system completely breaks down. Every 90 minutes, the station orbits Earth once. Every orbit brings one sunrise and one sunset. 16 times a day, the light changes from bright to dark and back again. Your brain, which evolved to handle one of those transitions per day, receives 16. The circadian rhythm receives 16 conflicting signals. It can't synchronize to any of them. NASA manages this with strict light schedules inside the station, using artificial lighting that mimics a 24-hour day. Astronauts are assigned sleep times. They use eye masks and earplugs. They are given melatonin supplements if needed. And even with all of that, almost every long-duration astronaut reports that sleep in space is one of the hardest adjustments. Not just the physical awkwardness of sleeping in zero gravity. The sleep schedule must be defended deliberately, against a window that is trying to confuse your biology 16 times every day. But here's where it gets strange. When astronauts are allowed to just look at Earth without a schedule, during off hours, or during what NASA calls Earth-gazing time, many of them report losing track of time entirely. Not because they're bored, because the visual experience is so continuous and so absorbing that the normal mental markers of time passing, meals, darkness, the movement of the sun, don't function the way they should. An astronaut can sit at the window for what feels like 20 minutes and discover that 2 hours have passed. Time, it turns out, is not just a measurement. It's something we construct from environmental cues. Remove the cues, and the construction becomes unreliable. Scott Kelly, in his memoir, described standing at the cupola window, the large observation module with 7 windows pointing toward Earth, and feeling genuinely uncertain how long he'd been there. Not in a frightened way, in a way that made him realize how much of his normal sense of time depended on things he'd never thought about. Let's come back to that blue line, the atmosphere. From the surface of Earth, the atmosphere feels enormous. It goes up and up and up, and there's no sense of where it ends. The sky seems infinite. Stand on a beach and look up, and the atmosphere contains everything. Clouds, weather, birds, aircraft, the whole human system of air travel. It feels vast. From orbit, it looks like paint. The breathable portion of Earth's atmosphere, the part where you could survive, the lowest layer called the troposphere, is about 12 kilometers thick. The ISS orbits at 400 kilometers. That means the layer of air keeping every living thing on Earth alive is roughly 3% of the distance between the station and the surface. Here's a comparison that makes it feel real. If the Earth were the size of a basketball, the breathable atmosphere would be thinner than a single piece of paper wrapped around it. That's it. That's all of it. And it doesn't stop there. The really thin part, the part where the atmosphere fades into space, is called the exosphere, and it extends out to roughly 10,000 kilometers. But that's not where the air is. That's where individual molecules occasionally float. You could be in the exosphere and still suffocate. The atmosphere that matters, the atmosphere that makes Earth livable, ends in about 12 kilometers. Astronauts who see this for the first time consistently describe the same reaction, a sudden, acute awareness of how contingent everything is. The word contingent is philosophical. It means depending on something else. Life on Earth is contingent on that thin blue line. Everything that has ever lived, every ecosystem, every civilization, every human story, all of it depends on a layer of gas so thin that from 400 kilometers up, it looks like the edge on a piece of fruit. Imagine looking at that. Imagine what it does to the inside of your head. Astronauts return to Earth after months in space, and they are physically broken down. Their muscles have weakened. Their bones have lost density. Their cardiovascular systems have shrunk because the heart, in microgravity, doesn't need to work as hard to pump blood. Their eyes have often been affected by increased intracranial pressure. Some long-duration astronauts have permanently impaired vision. Their immune systems are compromised. Their sleep is disrupted. The physical recovery takes months, sometimes longer. But the other changes, the ones that happen inside their minds, are more complicated to measure. Many astronauts describe returning to Earth and finding it almost unbearably beautiful for a period of weeks. The smell of rain, the sound of wind through trees, the feeling of weight and pressure underfoot. These are things that had been background noise for their entire life before launch. From the outside, they become astonishing. Mike Massimino, who flew on 2 space shuttle missions to repair the Hubble Space Telescope, described landing and being struck by the color of grass. Not the concept of it. The actual experience of seeing green in that specific way, reflected off actual living things in full atmospheric light. He said he stood there and stared at a lawn for what felt like a long time. And then there's the harder part. Several astronauts have described what can only be called a grief, a sense of loss, not just for the experience of being in space, though that is real, but for the way of seeing that space produced. The overview effect, that sense of clarity about Earth's fragility and human scale, doesn't translate cleanly back to a planet where the borders are visible again, where the problems feel enormous, where the atmosphere looks like it goes on forever because you're inside it. They carry both things at once, the knowledge of what the view looked like and the reality of a world that looks completely different from the inside. There's a photograph taken in 1990. A spacecraft called Voyager 1 had been traveling for 13 years, past Jupiter, past Saturn, past Neptune, out toward the edges of the solar system. Astronomer Carl Sagan requested that the cameras be turned back toward Earth for one last look before the equipment was shut down. What came back was a single image. Earth, from a distance of 6 billion kilometers, is a pale blue dot, barely a pixel, adrift in a beam of scattered sunlight. Sagan wrote about it. He said that every human being who had ever lived, every king and farmer and warrior and child, every moment of human history, all of it had happened on that dot, that mote of dust suspended in a sunbeam. Astronauts who see Earth from 400 kilometers feel something like what that image is trying to say, not as a thought, as a physical sensation, as something that enters through the eyes and doesn't leave. What they see out there isn't just the universe, it's a mirror, and what looks back is something smaller and more fragile and somehow more precious than anyone expected.